Double replacement reactions are a common type of reaction. Precipitation reactions are a common type of double replacement reaction. By looking at whether a compound is soluble in water, we can predict whether a reaction occurs if we can write a net ionic equation. Ugh, I ate too much and have acid indigestion. Chemistry to the rescue. The active ingredient in Tums is calcium carbonate. The active ingredient in milk of magnesia is magnesium hydroxide. We can make these antacids by doing a double replacement precipitation reaction. Indigestion and heartburn occur when the pH in our stomach drops below 2. An antacid reacts with and neutralizes acid and raises the pH back to its normal levels. This table shows the properties of various antacids. In this course, we'll look at these 3 reaction types. In this video, we'll focus on double replacement precipitation reactions. In a double replacement reaction, compound AB reacts with compound CD. Ion A combines with ion D to form one product. Ion C combines with ion B to form the second product. In a precipitation reaction, one of those products is insoluble in water. In a precipitation reaction, we want to be able to use and apply a solubility rules table. Remember, if you're not part of the solution, you're part of the precipitate. Here is the solubility rules table. Stop the video, take a picture of this table, and refer to this table when we're doing these precipitation reactions. So how do we use this table? For example, sodium is a group 1A alkali metal. This table tells us all sodium compounds such as sodium chloride are soluble in water. Here's another example. Compounds that contain the hydroxide ion or the carbonate ion are insoluble in water. There are some exceptions. When sodium combines with hydroxide to form sodium hydroxide, that compound is soluble in water. Hopefully you've never had kidney stones, but the formation of kidney stones is a solubility problem. So let's use the solubility table. Let's say we have all these ions in solution. Which ions combine to form precipitate? Stop the video and answer these 2 questions. And the answer to question 1 is no, because all sodium compounds and chloride compounds are soluble in water. For question 2, phosphate compounds are insoluble in water, but potassium is a group 1A or alkali metal. So when phosphate combines with an alkali metal, potassium phosphate is soluble in water. So here's how kidney stones form. Calcium, which is an important ion in our body, can either combine with phosphate to form insoluble calcium phosphate, or it can combine with oxalate to form insoluble calcium oxalate. All the oxalate ions are found in foods such as spinach. The best way to prevent kidney stones is to drink a lot of water. Here's an application of solubility. Let's say we want to remove an ion, in this case chloride, from the solution. What substance can we add which reacts with chloride, which forms an insoluble solid, that is, a precipitate? Stop the video and name 2 substances that you could add. And the answers are silver, lead, or mercury ions according to the solubility table. Here's another application of solubility. Let's say we have 2 ions in solution and we wanted to separate them. What substance would you add that removes one but not the other? Stop the video and identify that substance. Here's the answer. Calcium combines with sulfate to form insoluble calcium sulfate. According to the solubility table, strontium ion and barium ion will also work. Earlier we said we could do a precipitation reaction to make calcium carbonate the active ingredient in Tums antacid. We want to choose 2 reactants. For example, let's mix sodium hydroxide with calcium nitrate. Stop the video and answer this question. And the answer is... Let's take a look at this reaction in more detail. Stop the video and predict the products of this reaction. Remember, this reaction is a double replacement reaction. And the answer is... Here's what's happening. In a double replacement reaction, compound AB reacts with compound CD. A combines with D to form one product. C combines with B to form the second product. So in this reaction, A is... Stop the video and fill in the other blanks. And the answers are... Refer to a table of common ions to help you with the charges. So A combines with D to form, and C combines with B to form. Note calcium has a +2 charge, hydroxide has a -1 charge. That's why we need 2 hydroxides for every 1 calcium. Now that we have the correct chemical formulas, then we can use coefficients to balance the chemical equation. We did this reaction on paper, but does this reaction really occur? We can predict that this reaction occurs if we can write a net ionic equation. In a net ionic equation, the ions that are participating in the reaction are shown. The ions that are not participating are called the spectator ions. A net ionic equation tells us what's happening in solution. Some compounds will break up into ions, others will not. To write a net ionic equation, we want to be able to classify each compound by its compound type. So stop the video and review these rules. Going back to that equation to make lime for fertilizer, the compounds that are soluble are, we want to break up those soluble compounds into ions. Note how we carry the coefficients in sodium hydroxide and sodium nitrate, and how the subscript in calcium nitrate becomes a coefficient. Compare the reactant side to the product side in our ionic equation. Note that there's 2 sodium ions on each side, so we can get rid of those, and there's 2 nitrates on each side, so we can get rid of those too. The sodium ion and nitrate ions do not participate in the reaction. Those are spectator ions. What's left are the ions directly involved in this reaction. We can write a net ionic equation, therefore we predict that this reaction does occur.